All right, so we're going to work some actual AP problems. We're going to actually work some AP problems. We're going to start with 1988, BC1. So I'm going to make BC calculus students out of all of you and show that you can actually do BC work. All right. So number one, 1988 says, let f be a function defined by f of x equals x squared minus 3 times e to the x for all real numbers x. For what values is f of x increasing? So how do we find out when a function is increasing? We take the derivative. So for part A, we're going to take the derivative of your function. Which rule must we use? Product rule. So we're going to say first, which is x squared minus 3. The second, which is good, e to the x, plus second, which is e to the x times the derivative of the first, which is 2x. Now, before I find the zeros, I'm going to simplify by factoring e to the x out. And we're left with x squared plus 2x minus 3. Can you simplify that in all one step? Yeah. So that's f prime of x. And now we're going to set it equal to 0 and do a sign chart so we can figure out when this function is actually increasing. So e to the x times, does the inside factor, or the second set of parentheses factor? The answer is yes. So we're going to get x and plus 3 minus 1. Good. And now we're going to do our sign chart here. Now, is e to the x ever 0? No, so I'm going to superimpose that part of the graph on here. Here we go. I'm superimposing. It's always positive, never 0. And now I'm going to put the zeros for the quadratic, which would be negative 3 and 1. And I'm going to superimpose that quadratic on this sign chart. And it's going to be what kind of quadratic?
Positive.
Positively opening. And if I do a sign chart here, we're going to get positive, negative, positive. So we can say then for part A, f of x is increasing over what intervals? Negative infinity to negative 3 and 1 to infinity. How did we know using calculus? That's right. So since f prime is greater than 0, and that's your justification. So that's 3 points out of 9.
It's a lot.
So we're happy. Right, part B says find the x coordinate of each point of inflection. How do we find points of inflection? Second derivative. And when I do the second derivative here, I have two versions. I have the first one that I took. Do you see it? The first derivative here, which has two product rules involved, or can I use the simplified version and just use one product rule? So let's do that. All right, so for part B, we're going to find f double prime of x. So that's going to be first e to the x times the derivative of the second, which is 2x plus 2, plus second, which is x squared plus minus 3 times e to the x. And then we're going to simplify. E to the x factors out, and then let's write it in order. So it would be x squared plus 4x minus 1. Now, why did you say that? Ooh, yuck, you're right. It doesn't factor, but this is, you guys are like BC folks right now. So what did we use? Well, we got to use to solve for x.
Quadratic rule.
Which has the discriminant in it, yes. So we're going to say x equals opposite of b, which is negative 4, plus or minus the square root of b squared, which is 16, minus 4 times 1 times negative 1, all over 2a, which is just 2. So x equals negative 2 plus or minus, now 16 minus a minus 4,
20.
or it's 20.
So it's root 5.
So it's 2
It's 2 root 5, yes. 2 root 5 over 2, which simplifies to negative 2 plus or minus root 5.
Cool.
Now let's do our sign chart for F double prime, because in order to have an inflection point, we have to have a sign change in the second derivative. So I have no idea what the value is of -2 minus root 5, so I'm just going to put that on my sign chart. And then -2 plus root 5. And those are the zeros of the second derivative. And how does this e to the x look? E to the x is always positive, never zero. And I'm going to superimpose now the parabola, which opens up to do my sign chart here. And what are the signs here? We go positive, negative, and positive. Good. So where are my points of inflection?
Isn't it just the points?
Well, it is because
Sun changes.
we're changing signs. Yes. So we would say F has points of inflection. Now, does this question just ask for the x values?
Yes.
Thank goodness, right? Because you want to put that back in the original? No. Points of inflection at x equals -2 minus root 5 and x equals -2 plus root 5. How did we know? Since using calculus, F double prime. That's right. F double prime changes signs. Now, is it enough for the derivative, second derivative to equal to 0? The reason it's not is because what happens if I had a plus, a 0 on the second derivative, and a plus to the right of that? It didn't change signs, did it? So it's still concave up. So it's not enough for the second derivative to be equal to 0. You have to have a sign change. Yes, ma'am.
So the points that you solve for, there can be less points of inflection than that. There can't be more.
Right.
Isn't that okay?
Yes.
Would this be a non-calculated?
Yes, it would be non-calculator. Number, yeah, it would be non-calculator in that year.
Well,
I know.
what
What?
about now?
But then
Now, number 1 on the free response and number 2 on the free response are calculated questions.
So it would-
But not in that year, wasn't. This was a non-calculated question back then. Back in the day. All right, so find the x and y coordinates of the point, if any, where f of x attains its absolute minimum.
That's a first derivative issue.
So we have to do
X of X chart.
we have to do a chart, right? But do I have any endpoints?
No.
Well, you can do limits.
So that's right. We got to do our limits. So what are we going to put on our chart? We're going to put x, f of x, and that's going to equal x squared minus, is it x squared minus 3
Yes.
times e to the x? And then we're going to put our critical points, which were -3 and 1. Is that right?
Yeah.
-3 and 1. And then we're going to do end behavior limits to help us out to see what our function is doing at the infinities here. To see where, if we have any absolutes. So what happens when I take the limit of my function as x approaches infinity? It's going to be something very large squared and e to the something large.
It's positive.
It's just very large, largely large. No? Guys, not laughing at me. Okay, here we go.
It's miniature.
What happens when I plug in negative infinity? That's going to be a positive number, right? And when you square a negative number, you get a positive large number.
Other one's positive.
But what is
Fraction.
E to the
Fraction.
-1,000,000?
Doesn't that just be a fraction?
Fraction.
Really small. How small?
Zero. Small.
Zero small.
So it's just 0.
This goes to 0, yes.
That's insane. So we have to put 0 in there now?
No. Watch what's happening here. Now we're going to plug in -3 into our function, and what do we get?
6
times
e
e
to
cubed.
6
1 over
e to the -3, right? Which is this. When I plug in -3, I get -3 squared is 9, 9 minus 3 is 6, times e to the -3, which makes that in the denominator.
Yep.
What happens when we plug in 1? We get
-2.
-2
e.
e. So, which one is the smallest there? And since this is rocketing off to infinity as x goes to infinity, this has to be the absolute min because at the other end it's approaching 0.
Sorry, I got
Yep.
one more if you don't mind.
All right, so then this is the absolute minimum, right? And I would put since here, right? Questions on that? And this is enough justification. Moving right along, right? Here we go. Now we're going to go back to 1987.
This whole exam has been all around for so
It
long.
has actually.
How long was the first one I had? It's like,
Miss Moore, did you take any of the exams?
I did.
did you
And I
get a
got a
five?
5. I sure did.
Yeah.
Right.
Okay, here we go.
If you didn't get a 5, you
I'm
wouldn't
sure
be
it was-
teaching.
Who knows? I loved it. So I would,
Was
Yeah.
it easy?
yeah, it was ABC. My school was not ABC.
Oh.
Oh,
All right, here we
we're
go.
just like you.
Let f of x be the function given by f of x equals 2 ln of x squared plus 3 minus x with the domain of.
Oh,
Negative 3 to 3.
Now, I'm circling this because
You will forget. And what you do not.
no. Those are endpoints.
that's a closed interval. Right?
Yeah.
Yeah.
So I might have to check the endpoints. So I would do this, if I were you, I would say this to remind yourself that this is closed. So you might, by the extreme value theorem, have to check the endpoint. So we'll just keep that in our mind. All right, so part A says, find the coordinate of each relative maximum point and each relative minimum point of f to justify your answer. So what do we need?
That XY chart.
We need a chart, don't we?
We need to take the first.
We need the first derivative. So we can say then that f of x, or f prime of x is equal to 2 times
2 times
1
2x
over.
2x
over x
X
squared
over,
plus
yeah.
3 times
Minus
negative
1.
1.
Minus 1.
minus 1. Because it's a derivative of negative x.
Oh.
We're gonna do it on this video.
Yes,
Sorry.
for all time. Okay, so I'm going to simplify this and get 4x over x squared plus 3 minus 1. And I have to set this equal to 0, so I need to find a common denominator. So 0 equals 4x times negative. What do I have to give this one? I have to give it,
Minus x squared plus 3.
yeah,
Minus x squared minus 3.
right, we have to distribute that pesky negative. Everybody all right with that?
Why can't you add 1 on both
Yeah,
sides?
we got one.
Oh, you did it.
Because what do we need to find out? When we're doing curve sketching, you need to have a numerator and a denominator to find the critical points because you need to find out when it's equal to 0 or undefined. So I never move anything to the other side and solve
Okay.
because you need that denominator
Okay.
to help you with the critical points being undefined. All right? Now, is it wrong to try to solve it that way? No. But for calculus, we need to have that denominator. Okay? So we want a rational function equal to 0. Okay? So let's simplify this and we get negative x squared plus 4x minus 3 all over x squared plus 3. Now, I don't like to factor with a negative in front, but I'm going to leave the negative out and factor it out. And I need it out there because to do the sign chart, I've got to remember that it's upside down. Okay, so if I factor the numerator, what do we get? Because this turns out to be x squared minus 4x plus 3.
Minus 3 minus 1.
So this is x and x
And then x
minus
plus
3
x minus 1.
minus 1.
No, because that's
Plus plus.
Minus
If you
minus.
factor that a negative, it's plus plus.
No, this is
No,
negative
it's
and
not.
this is,
Never mind.
right,
No.
okay. Would you agree with that? Now are we ready to do an F prime line?
Yep.
Line chart? So, let's talk about the numerator. It's a parabola that opens upside down. What are its zeros?
3,
Yep, 1 and 3. And if I were to superimpose,
1.
it's opening
Yes.
down because we factored out a negative. Good. And now let's talk about the denominator. What's the denominator doing? It's a parabola that opens up. Does it have any zeros?
Never.
No.
X squared plus 3. That's floating above.
It's a floater.
It's a floater. Yeah. Agree? Yes. Now let's do the sign chart. What do we get? Negative, positive, negative. So now I need to find some extrema, but I have to also remember that I had some endpoints. What were they?
Negative.
Negative 3 and 5. So I'm going to put those on my sign chart. So if I do the slope analysis here, we've got a negative slope to a 0 slope to a positive slope. That's a minimum. And then we have a positive slope to a 0 slope to a negative slope, which makes it a maximum. So we're going to do our chart. So what goes on our chart? Negative 3, 1, 3, and 5. And f of x was equal to 2 natural log of x squared plus 3 minus x. So let's figure out what our values are. What happens when we plug in negative 3?
Natural log is 6.
12. That one, 12.
12. This is 2 natural log of 12 because 3 squared is 9. Plus 3 is 9. Minus a minus 3. What happens when we plug in 1? We get 2 natural log of 4 minus 1. When I plug in 3, we get 2 natural log of 12 minus 3. What happens when I plug in 5?
2 and 28 minus
28 minus 5.
That's right.
All right. So we have to figure out what's going on here. Well, we already know that this one is at 1. We know that's a minimum of some sort.
When we go at 3, it's a natural.
But is part A asking for any absolutes?
No.
So what's it asking for?
Relative.
So we can say that what's happening as I leave negative 3 to my function, it's
Going down.
decreasing. So what is this point? It's going to be a maximum. So this is a relative max. And then we know we have a relative min,
and then a
relative max.
and then
What happens now when I leave f x equals 3? I'm going down again, so that's going to be a relative min. Now, how did I know that at 1 I had a relative minimum?
Because the slope changed.
So it's going to be f prime was less than 0 to f prime is greater than 0. I knew I had a relative max at 3 because f prime was greater than 0 to f prime is less than 0. Nice recovery, right? Okay, so now, how did I know that I had a relative max on at a negative 3? The derivative to the right of it was
Negative.
Smaller.
what? Was negative, right? So we can say f prime less than 0, and I usually put to the right because it's on the right side of it, right? What about, how did we know that we had a relative min at 5? F prime was less than 0 on the left at that point.
And
How do
It's decreasing till I get there, so it has to be a minimum.
The first one, -3.
Okay, what's happening? I'm decreasing after I leave it.
What is
So it has to be a high point.
Okay.
How do we know?
Wouldn't they be opposite sides?
Hold on, I got two questions. So,
How do we know that none of these are absolute?
well, we're not ready there. That's part C. Yes,
The signs are the same though.
doesn't matter.
So is it just
When I'm
No, but
leaving,
the-
low to low? No, but you said you have F prime is less than 0.
And then at the
Or
bottom,
negative
F
three.
prime is less than 0.
is it negative, is F prime negative after -3?
Yeah.
What about F prime negative before 5?
So why would one be a minimum?
Okay, because what's happening when I leave -3? What's my function doing
It's going,
Oh,
when the derivative is negative?
It's going down.
Decreasing, so I had to leave from a maximum. A great question. And then what happens as I approach 5? I'm decreasing to get to 5, so that has to be a minimum.
So it's like a,
Yes, right? You follow
yes,
that?
I got you now.
Okay, all great questions. All right, so part B, find the x-coordinate of each point of inflection. Now, before we start crying, we're going to take the derivative of this second one, right? Because that's a lot easier. What's the derivative of -1? That's the easy part.
0.
0. And then we have to use the quotient rule once, because this is the first derivative, right? So I'm going to rewrite the first derivative so I don't forget it. So part B is f prime of x was 4x over x squared plus 3 minus 1. So f double prime of x is equal to Ho.
X squared plus 3 times 4.
d high, which is 4, minus high, which is
4x
times 2x, all over ho, which is 2x squared plus 3 quantity squared. Simplifying the numerator, 4x squared plus 12 minus 8x squared, all over x squared plus 3 quantity squared. So what happens now? We get 12 minus 4x squared, good, all over x squared plus 3 quantity squared. So now I need to find the zeros for the second derivative so I can do a sign chart for it. So I set the numerator equal to 0, 12 minus 4x squared equals 0. Can I factor out a 4? And I get 3 minus x squared. So do we see how it's plus or minus root 3?
Yes.
You could do this.
Bottom's okay.
And the bottom, yeah, tell me why. You're right.
Because if you square a number, it can't be negative. You're adding 3.
That's right. So, but if I were to superimpose this, where would it be?
The top.
Above, yes. So let's do that. This is the denominator up here somewhere. And what about the numerator is a what shape?
Negative parabola.
Negative parabola. So I'm going to superimpose that here. We got a lot of that going on, don't we? 0, 0. Let's do our sign chart. Negative, positive, negative. So they want the points here for the
Yeah, the coordinates of each inflection point.
just the x coordinate.
Oh, yeah.
Oh,
Easy
good.
done.
So we can say
Negative root 3.
F has points of inflection at x equals plus or minus root 3 since
Signs change.
F double prime changes signs. That's nice. Is that the last part of this one?
No, absolute maximum value.
Absolute maximum value. What 2 points must I consider?
The relative maximum. -3.
Okay, so I'm going to put those on my chart.
Are all absolute maximums and absolute mins relative maximums?
Yes, they are. Yes, they are. So where do those occur? At -3 and 3. These were my relative maxes. So we already plugged them in, didn't we? We got 2 natural log of 12 plus 3, and 2 natural log of 12 minus 3. And so which one has to win on the largest?
Plus 3.
Yeah, so this one right here is your
Yeah.
absolute max. Yeah, it was. Because they only asked us for an absolute max. It would have been more difficult had they asked us for the absolute min, I think.
So would you,
Oh, yeah, so.
Because it would have been harder to compare those numbers.
So
If they made us find a relative min, would we have a calculator?
Yes.
Okay.
up there, so
Mhm.
we don't change that, even though it's the same.
Right. All right, moving right along because I want to finish this. I got 5 minutes.
We can do it.
All right, so what I do, this is the problem, it says that this is a graph of the derivative. Most people forget that this is the derivative, so I write it in big letters so I know it's a derivative. And I'm going to do an F prime line. What is an F prime line? That means I'm doing a sign chart for the derivative. Does this have any zeros, this derivative function? Where?
-2,
Good.
2.
0 and 2. What are the signs of this function to the left and the right of these? Well,
Positive.
positive y value,
Positive.
negative, positive, positive. Yes, very nice. If I were going to do an F double prime line, that's going to be a slope to this function, isn't it?
Yep.
Do I have any zero slopes? Negative 1
Positive 1 and 2.
and positive 1 and 2. What kind of slopes do I have to the left?
Negative.
Good, negative. To the right of negative 1. To the right of 1. Negative, and what kind of slopes to the right of 2? Positive, okay? Now, I'm going to take this information here. I'm going to cheat a little bit. I'm sorry.
Oh,
And I'm going to put it below here. Is that all right?
yeah.
Wow, that's huge.
That is big.
Okay? And I'm going to work part 3 first, if that's all right with you.
Sure.
Or part C first. It says, use the information and graph it. Because this is what we had a question on earlier, right? So they're telling me the f of -3 is 0. So where am I going to put a point? Right here, boom, that's where I'm starting. So this says, the graph down here, this says my function is increasing because it's positive and concave down. What does that look like? What does that piece look like? Increasing and concave down until 1, it says, right? Till -2, right?
Yeah.
And then what is it doing? It's decreasing and concave down until -1. So could we say it looks like this?
Yes.
There are infinitely many answers to this. What did I do? I said this is increasing and concave down, right?
Yeah.
So this piece looks like this. This says I'm decreasing and concave down. So this piece looks like this. This now I'm going to say decreasing and concave up. What does that look like? Decreasing and concave
Exponential.
up until 0.
Yeah.
And then it says after 0, I'm increasing now and
So
concave up. So it's going to be the other piece until 1. Here we go. And then it says after 1, I'm increasing concave down to 2. There we go, increasing concave down to 2. And then after that, I'm increasing in. So what's that look like?
Well, okay. It only goes to 3.
Right, I know, but I shouldn't have drawn it past 3.
Interesting.
do you put a dot on it?
I'd leave it like that. Okay, so does anybody have any questions on that? I got 1 minute. Using the sign chart, how do I know where this has a relative minimum? I'm going to do the slope thing. Here, I have a max. This one is a min, and this is a Nothing. Right?
Okay.
But they're asking for the open interval, so I don't have to entertain any endpoints here. So I would say relative max at x equals negative, whoop,
Min or max?
that's a max. -2 since f prime greater than 0 to f prime less than 0. And then we have a relative Min.
Equals 0.
at x equals 0 since
F prime less than 0.
Good afternoon, everyone. Let's prepare for our afternoon announcements.
how do I
Before
deal
your
with
announcements,
concavity?
Attention, Society of St. Vincent de Paul.
So I can
Our
say
t-shirts have arrived. Please
Concave
Miss
up
Velarde to pick yours up.
from
We have a variety of names ready to go places, so
And?
please pay attention.
2 to 3 since
Dominic Maracoccio, please go to the
f double
zone.
prime of x is greater than
Following
0.
students, please see Miss Hart.
And there we
William
go.
Knight Lotus,
Woohoo!
Nick Vando, and Marcus Sullivan.
Thank you for your kind attention.
Marcus Sullivan and Ben Hammer.
So, Marcus,
Peter Griffin.